Okay, part 2 of the video. So we're going to see a secondary survey at a confidence level of 90% found that 10% of the pills were substandard with a confidence error of 4%. Approximately how many people were surveyed? Okay, so 90%, going back to our chart. So 90%, we just did, we did 90%, it's 1.645. So Z is 1.645. Okay, so we have confidence error. So that's the same as margin of error. So this would be our E. This would be our E value, which is 0.04. Okay, again, I'm listing out what I have. How many people were surveyed? So this is what I need to find, which is our N value. So I have an E, a Z, and an N. Okay, so looking at our formulas, we're going to need one more piece of information, which is the 10%, which would be our P. So our P would be 0.1. Okay, so we're going to substitute it in. So E equals Z square root P 1 minus P over N. So Z 1.645. Okay, our percent is 0.1 times 1 minus 0.1 is 0.9 over N, which we don't have, and I forgot my E is 0.04. Okay, now we have to isolate for N. Okay, so we're going to, since we're multiplying by 1.645, we're going to divide by 1.645. So that gives us 0.0243. Goes the square root. If we multiply these two, we get 0.09 over N. Okay, so now we need to keep still isolate for N. So we have a square root. So we're going to square both sides to cancel out our square root. So we get 0.00059 equals 0.09 over N. Okay, this one I'm going to take a different kind of root. I want to get rid of this denominator, so I'm going to multiply by N on both sides. So I get 0.00059N equals 0.09. And lastly, I want to isolate for the N, so I'm going to divide by 0.00059 on both sides. And I get an answer of approximately 153. So roughly 153 people were asked. Okay, moving on to, one second. All right, moving on to number 3. Told you this would be a long lesson. Just trying to cover. Usually I split this into 2, but since our year is coming to a close, I need to do this in 1. All right, a consumer group tested batches of light bulbs. So again, this is like kind of a quality control to see how long they lasted. The results are from one batch, are showing how long that the light bulbs will last. Okay, the manufacturer claims that the life is normally distributed with a mean. So we have an average, so a mean of 1200. Okay, and a standard deviation, so standard deviation 420. Calculate the mean of the samples and the standard deviation of the sample means. Okay, so we want to calculate the average of the sample. Okay, so we're just going to this is the sample here, so we are going to find the average. So in order to do that, we add them all up together and divide by how many there are. Okay, so I'm not going to list every single one. So we add them all up together and we divide it by 12 because there were 12 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, when you add them all up and divide by 12, you get an answer of 1,233 hours. Okay, so it means that the light bulb, on average, will last 1,233 hours. Okay, then the second part says the standard deviation for the sample means. Sample means. So key word there, sample means, I told you. So from the first page, when it says sample means, we're going to be using this formula here, and that gives us the standard deviation. So we have, this is standard deviation of the sample mean. So it's the standard deviation divided by the total number, the square root of the total number. So the standard deviation is given already, which is 420. And we're dividing by the square root of our number, which is 12. And when you do that, you get 121. Okay, so the standard deviation would be 121 for the sample means. Okay, again, that means how far apart. Remember, the standard deviation tells you the average distance of value is away from the mean. So any given value would be about 121 hours away from this average here. Okay, so determine the 99% confidence interval for the sample mean. Okay, confidence interval. Okay, so we're doing interval again. So we want our lower and our higher. So we want our lower end and we want our higher end. Okay, so we're not given any percents in here. We're not given any percents inside of our questions. So we are beginning using the second formula here, okay, which is the that's your mean plus or minus the standard error. So we're going to take our average, which is 1233, and we're going to subtract and add our standard error, which we don't have it yet. So our standard error is Z times standard deviation divided by the square root of n. So minus Z times and I'm going to add it on this side as well. So 1230 subtract. So our Z score is based on this confidence interval. So a Z's confidence interval of 99% is 2.576. So we get 2.576 times our standard deviation, which we said was 420, divided by square root of 12. Okay, so when you do all this, I'm going to skip some steps. You get an answer of 921. And when you do the same on this side, you get an answer of 1545. Okay, so our range, our confidence interval, is from 921 hours to 1545 hours. So what that means again is that if you were to take another light bulb or do another sample again and you find the average, that means your average will be within these two values. So from 921 hours to 1545 hours, 99 out of 100 times. Okay, so that means if you did it 100 times, 99 out of 100 times, you will get a value between these. Okay, between 921 and 1545. Okay, moving on to our last one. As part of Earth Day celebrations, an environmental scientists participated in a program to measure the water clarity in 60 locations in Lake Ontario. using a clarity measuring disc. By the way, Lake Ontario is actually very clean. It is extremely, years ago it wasn't very much, but right now Lake Ontario is actually a very clean lake. The scientists reported that the lake water was clear to a mean depth of 6 meters with a standard deviation of 1.5. The margin of error was 0.25. What confidence level was used? Okay, so we're looking for confidence level. So let's list out what we have. So first thing, 60 locations. That would be N. Okay, what else do we have? Next is a mean depth of 6 meters. So mean is their average. And since it's a sample, it's X bar. So our sample is 6. Sorry, our sample mean or our average is 6. Standard deviation of 1.5. So standard deviation of 1.5. Okay, we have a margin of error, which is 0.25. So an error, 0.25. And in order to find confidence level, remember confidence level is here, confidence level, we need to know the percentage. So in order to find the percentage, the confidence level, we need to know the Z-score. So what we're not given is the Z-score. Okay, so now we have to connect this to a formula. So which one would have these values connected to them? Okay, so in the first formula, we do not have any P's, so we can't use the first one. Our second formula here, so we have E, we're looking for Z, we have standard deviation, and we have our N value, so we could actually use this formula here to help us find the Z-score. So let's write that out. So E equals Z, standard deviation divided by square root of N. So our E is 0.25. Z we do not know. Standard deviation is 1.5 and square root of N, which is square root of 60. Okay, in this case, we didn't need to use our average. Okay, so it's just a number that was given that we do not need to use. Okay, so we now isolate for Z. If you do 1.5 divided by a square root of 60, you get 0.1936. And then divide through. You get an answer of 1.29 as your Z value. Okay, but this is the trick question. So we get an answer of 1.29, okay? What happens here is we did 1.5 divided by the square root of 60, okay? Whenever we do a square root, you actually get two answers. You get two answers. You get the positive answer and the negative answer, okay? So this answer here is positive 0.1936, but it's also negative 0.1936. So you get two answers here. You get positive 1.29 and negative 1.29. So we have two Z-scores. So we have a Z-score of 1.29 and a Z-score of negative 1.29. Okay, so we have to find now, we now have to find the confidence level. Remember, confidence level is a percentage. So since we have our Z-scores now, to get the percents, we then go to the table. So we need to go for the table to get the percentages. So we go to our trusted table here. Okay, negative values on the back on one side and positive values on the other side. So when you look up on the table, you get a 0.90